is on the area of a parallelogram and a triangle. Remember, area is the amount of space that a shape takes up. So an example would be like the tile in your kitchen or the carpet in your bedroom. That would be an example of area. Okay, so uh, a parallelogram has an area of base times height. Rectangles, squares, those are all parallelograms. Those have a area formula of base times height. Okay, now the base of a parallelogram is any of its sides, and the corresponding altitude is the height. Okay, so the height of a parallelogram is always perpendicular to its corresponding base. All right, sometimes the base will be the side, all right, on the left side here, and then the height that corresponds to it must be perpendicular to that base. So here's a couple of examples here. So for this, we have area equals base times height. And I know I have two bases here. I have a base of 4.5, and I also have another base of 5. Now, only one of these has a corresponding height. This is the height, 4 inches, and it's perpendicular to this base down here. So I'm not going to use 4.5. So it's going to be 5 times 4, which would be 20 inches squared. Okay, same thing over here with example B. Area of a parallelogram is base times height. Okay, 2 is a base, and 4.6 is also a base. 3.5 would be the height. The height, 3.5, is perpendicular to an extension of this base down here, so I'm not going to use 4.6. So this is going to be 2 times 3.5, which is 7, in this case, centimeters squared. Okay, so moving on here, here's another example. We're going to find the area of this parallelogram. So I know 12 is a base, and 10.5 is also a base. 8 would be the height. Now this height is perpendicular down here with the base labeled 12, so this 10.5 would not be used. So area equals base 12 times height 8. If you do that correct, it should be 96 square meters. All right, now we have area in a coordinate plane. So here's an area, here's a parallelogram that's graphed for us, and we're going to find the area of this parallelogram. So again, area of a parallelogram is base times height. All right. Now, I'm going to use this base on the bottom because it's easy to count. So it's 1, 2, 3, 4, 5. And this height is 3. So that simply be 5 times 3, which is 15 units squared. We use units on a graph. Okay, here's another example. This one asks us to graph it ourselves. So we're going to find the area of parallelogram ABCD with vertices. A is negative 2, 0. So I'm going to plot that point. Negative 2, 0 is here, so that's point A. B is 0, 5. Let's see, 1, 2, 3, 4, 5. There's point B. C is 8, 5. 1, 2, 3, 4, 5, 6, 7, 8, and then go up 5. 1, 2, 3, 4, 5. There's point C, and D is 6, 0. So 1, 2, 3, 4, 5, 6, 0. So there's point D. So you can see here's our parallelogram. And we're going to figure out the area of that parallelogram. Again, area is base times height. All right, this base, if I count all the way across, that'd be 1, 2, 3, 4, 5, 6, 7, 8. And the height is, we can use this height right here. The height here would be 1, 2, 3, 4, 5. So it'd be base 8 times height 5, which is 40 units squared. All right, so that wraps up a parallelogram for you. Here's another example of how to find a missing dimension. So for parallelogram ABCD, we're going to find CF to the nearest tenth. So CF is a height. Okay, now this height is perpendicular to the base 13. So I'm going to come over here and write out my formula. Area equals base times height. Okay, I know the base is 13, and the height is what I'm trying to figure out. All right, now for this area, I need to figure out the area of this parallelogram. Now I'm going to do that using the base of 10 and its corresponding height of 12. So I know area of this parallelogram is base 10 times height 12, which is 120. So I can plug that in over here to this little equation I've set up. Now I'm going to solve this for h. So I'm going to divide both sides by 13. Sorry, by 13. Those cancel, and our h would be 120 divided by 13. And we're going to round that to the nearest tenth, and you should get approximately 9.2 inches. So let's try another one of those missing dimension problems. Okay, here's a parallelogram that has a 9-inch and 18-inch sides. So let's go ahead and draw a diagram. There's a parallelogram. So we have 9-inch and 18-inch sides of the parallelogram. Those are both bases. The height corresponding to the 9-inch base is 15 inches. So this height right here is 15 inches. And what it wants me to find is the height corresponding to the 18-inch base. So that would be something like that height here. So that's the height I need to find. So area equals, again, base times height. All right, the base I'm going to use for my equation is 18. And I need to find the corresponding height, which I don't know. And I got to calculate the area. I'm going to use the other two dimensions to calculate the area, which is 9 times 15. So the actual area of that parallelogram is 135. So I'm going to plug that in over here, 135, and solve this equation for h. So I'm going to divide both sides by 18, and h equals, let's see here, 135 divided by 18 is exactly 7.5. So I have found that missing height. Okay, next we're going to talk about the area of a triangle. Okay, a triangle is half of a parallelogram. So the equation for the area of a triangle is 1/2 base times height, or you can take base times height divided by 2. Okay, whatever formula works best for you, you can go ahead and use that. It's the same mathematical operations. All right, let's define what a base of a triangle is. Base of a triangle is any of its sides. Okay, so every triangle has 3 bases. The corresponding height is the length of the altitude to the line containing that base, and it has to be perpendicular to that base. So for this first example, I know 10 is my base because that's a side of the this triangle. Okay, and this 6.4 will be my height because it is perpendicular to an extension of that side. This length is not used. That's there to trick you. So area of a triangle is base times height divided by 2. Plug in my information. I have 10 times 6.4, and then I'm going to divide that by 2. So if I calculate that correctly, you should get 32 square feet. Let's try another triangle problem. All right, here's the area of triangle XYZ, and we have some dimensions given to us. Now I know both of these are bases because those are sides of the triangle. I know this is a height because it's making a right angle with one of the bases. Now this 13 is making a right angle is perpendicular to the base YZ. So I'm going to use the 30 and not this base because the 31 does not have a corresponding height. So again, we're going to go area equals base times height divided by 2. Okay, I'm going to plug that in. Let's see, we got 30 times 13, and then divide that by 2. So 30 times 13, and then divide that by 2, and you should get 195 centimeters squared. All right, the last type of problem we're going to talk about is a shape that is a combination of 2 familiar shapes. So in this, and right now we're going to ignore all this, and what I want to do is, I just want to know what is the area, what's the area of this entire shape. Okay, now this shape is made up of 2 shapes that we know. We have the triangle on top, so if I take that triangle out of there, it has a height of 6. Now this base down here, this base is the same as the base of the rectangle, 20. So I can calculate the area of that triangle as base 20 times height 6 divided by 2. So 20 times 6 divided by 2 is 60. Then I can take the rectangle out and label its dimensions and then find the area of that. Now that's a parallelogram, so base times height. So it's 20 times 12, which is 240. Now I'm going to add these two areas together to get the total area. 60 plus 240 will give me 300 square feet. Okay, that's how you're going to calculate areas of shapes you're unfamiliar with. You want to break it apart into familiar shapes that you know the formula for. Okay, and that wraps up this lesson on the area of parallelograms and triangles.